Good morning, children. Welcome to your maths class. In the last class, we had solved some of your exercise problems. Let us continue that. In today's class, we will going to solve the remaining mains in your exercise 2.1. Okay, children? Are you ready? Yes. Here is your third question. Consider two postulates given below. Here is the first postulate. Given any two distinct points A and B, there exists a third point C which is in between A and B. And in the second postulate, there exist at least 3 points that are not on the same line. Do these postulates contain any undefined terms? Are these postulates consistent? Do they follow from Euclid's postulates? Explain. Here they had given two postulates and you have to say, do these postulates contains any undefined terms? Children, you know that what are undefined terms and why it was remained as undefined. Remember, I had explained it in my previous videos, isn't it? Now tell me the three undefined terms in Euclid's geometry. Yes, good. The undefined terms in Euclid's geometry are a point, a line, and a plane. So, can we say the postulate that is given here contains some undefined terms? No. In these two postulates, the undefined terms are a point. Here is a point, and in the second postulate, here a line. These two are the terms that you have to that we called it as a undefined terms. And in the second question, yes, they asked that are these postulates consistent? Yes. Let me explain now. What do you mean by this consistent? If there are no contradiction between two postulates, then we called it as a consistent. Here these two postulates are consistent because they refer to two different situations. Let me explain it. Okay, in the first postulate, they given that any two distinct points A and B, there exists a third point C which is in between A and B. Here there is 2 points A and B and another point C which is lying between this A and B like this. These three are the lines. If C is in between A and B means what? These 3 points are in the same line. So can I join these three points through a line segment like this? Now you observe this C is in between the points A and B and it is in the same line, means these 3 points are collinear. You understood the first postulate? In the second postulate, they take 3 points that are not on the same line. Let me explain it. Here there are 3 points which are not on the same line. D, E, F are the 3 points which are not collinear. So in these two, observe these two postulates. Here these are the different points which are collinear and these 3 points are not collinear. So they are talking about two different situations. ಅಲ್ವಾ ಇಲ್ಲಿ ಎರಡು ಬೇರೆ ಬೇರೆ ಸಿಚುವೇಶನ್ ಬಗ್ಗೆ ಅವರು ಹೇಳ್ತಾ ಇದ್ದಾರೆ. ಇಲ್ಲಿ 3 ಪಾಯಿಂಟ್ಸ್ ಇದೆ, ಅದು ಕೊಲಿನಿಯರ್ ಆಗಿದೆ, ಒಂದೇ ಲೈನ್ ಮೇಲೆ ಇದೆ. ಇಲ್ಲಿ 3 ಪಾಯಿಂಟ್ಸ್ ಇದೆ, ಅದು ಒಂದೇ ಲೈನ್ ಮೇಲೆ ಇಲ್ಲ ಅಲ್ವಾ. ಇಲ್ಲಿ ಈ ಸೆಕೆಂಡ್ ಪಾಸ್ಟುಲೇಟ್ ಅನ್ನೋದು ಫಸ್ಟ್ ಪಾಸ್ಟುಲೇಟಿನ ಕಾಂಟ್ರಡಿಕ್ಟರಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ಆಗ್ಲಿಲ್ಲ. ಅಂದ್ರೆ ಈ ಸೆಕೆಂಡ್ ಪಾಸ್ಟುಲೇಟ್ ಅನ್ನ ನಾವು ಪ್ರೂವ್ ಮಾಡಿದಾಗ ಫಸ್ಟ್ ಪಾಸ್ಟುಲೇಟ್ ಯಾವುದೇ ರೀತಿಯ ತಪ್ಪು ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಆಗ್ಲಿಲ್ಲ. ಇದು ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್, ಇದು ಕೂಡ ಕರೆಕ್ಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ these two postulates are not contradictory to each other, so we call these two postulates are consistent. Okay, let me summarize this. In the first postulate, given any two distinct points A and B, there exists a third point C which is in between A and B. Here the undefined term is point. Yes. and in the second postulate there exist at least 3 points that are not on the same line. Here the undefined term is line. And for the second question, yes, do these postulates are consistent? Yes, these two postulates are consistent. And in the last question, they asked that do these postulates follow from Euclid's postulates? They do not follow from Euclid's postulate, but they follow from Euclid's axiom. Yes, you know the axiom. They given any two distinct points, there is a unique line that passes through them. So this postulate follows Euclid's axiom, not Euclid's postulate. You understood, children? Okay, let us move on to the second question. Yes, here it is. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half AB. Explain by drawing the figure. Yes, here is the figure. AB is a two distinct point and C lies between the points A and B. And also they given that AC is equal to BC. Here this AC is equal to BC means what? C is the midpoint of AB. Now we have to prove that this AC is equal to half AB. Yes, we know that. If C is the midpoint of AB, obviously AC is equal to half of AB or BC is equal to half of AB. But here we have to prove it logically. Are understood, children? Okay, let us prove it. Here they given that AC is equal to BC. So we can take this AC is equal to BC. According to axiom 4, you know that things which are coincide with one another are equal to one another. Here the line AB is coincide with the line AC plus BC, no? So can we take AB is equal to AC plus BC? Yes, according to axiom 4, we can take this AB is equal to AC plus BC. And again you know that they given that this AC is equal to BC. So can we replace this BC as AC? Yes, here I am replacing this BC by AC. And then you simplify it, you will be get AB is equal to 2AC, means AC plus AC is 2AC. Now divide AB by this 2. Now you get half of AB is equal to AC, or AC is equal to half of AB. This is what you have to prove. You proved. You understood, children? Let us move on to our next problem. Yes, here it is. In a question 4, point C is called a midpoint of line segment AB. Prove that every line segment has one and only one midpoint. Here, we have to prove that every line segment has only one midpoint. To prove this statement, first we have to assume that there might be two midpoints are there to a line segment AB. Those two midpoints as P, okay, take those two midpoints as P and Q. Then we have to prove that P and Q are one and the same. Okay, let me prove here. Observe here. Here is a figure AB, and there are two midpoints P and Q. Yes, this is only the assumption. ಅಲ್ವಾ, ಯಾವುದೇ ಒಂದು ಲೈನ್ ಸೆಗ್ಮೆಂಟಿಗೆ ಎರಡು ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಇರುವುದಿಲ್ಲ, ಒಂದೇ ಒಂದು ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಇರುದು ಅಂತ ನಾವು ಅದನ್ನ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕೀಗ. ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡುವ, ಒಂದು ಅಸಂಪ್ಷನ್ ಮಾಡ್ಕೊಳುವ, ಹೌದು ಎರಡು ಪಾಯಿಂಟ್ ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳುವ. ಆಮೇಲೆ ಅದನ್ನ ಪಿ ಅಂತ ಕ್ಯೂ ಅಂತ ತಗೊಂಡಿದ್ದೇನೆ ನಾನಿಲ್ಲಿ. ಏನ್ ಬೇಕಾದ್ರೆ ತಗೊಳ್ಬಹುದು ನೀವು, EF ಅಂತ ತಗೊಳ್ಳಿ, GH ಅಂತ ತಗೊಳ್ಳಿ, ವಾಟ್ ಎವರ್ ಮೇ ಬಿ ದ ಸಿಂಬಲ್ಸ್. ನಾನಿಲ್ಲಿ ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಅಂತ ಹೇಳಿ ತಗೊಂಡಿದ್ದೇನೆ. ಆಮೇಲೆ ಏನ್ ಮಾಡುವ, ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಎರಡು ಒಂದೇ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಿದ್ರೆ, ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಎರಡು ಒಂದೇ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಿದ್ರೆ ಆಗ ಇಲ್ಲಿ ಒಂದೇ ಮಿಡ್ ಪಾಯಿಂಟ್ ಇದೆ ಅಂತ ಹೇಳಿ ಆಗ್ತದೆ. ಸೊ ನಾವು ಮಾಡಬೇಕಾದ ಕೆಲಸ ಈಗ ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಅನ್ನುವ ಎರಡು ಮಿಡ್ ಪಾಯಿಂಟ್ಸ್ ಇದೆ ಅಂತ ಅಸಂಪ್ಷನ್ ಮಾಡಿಕೊಂಡು ಆಮೇಲೆ ಅದೆರಡು ಒಂದೇ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡೋದು. ಓಕೆ, ನಾವೀಗ ಏನನ್ನ ಪ್ರೂವ್ ಮಾಡಬೇಕು? ಈ ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಒಂದೇ. ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಒಂದೇ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಬೇಕಾದ್ರೆ ಎ ಪಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎ ಕ್ಯೂ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡಿದ್ರೆ ಪಿ ಮತ್ತೆ ಕ್ಯೂ ಒಂದೇ ಆಗ್ತದೆ ಅಲ್ವಾ? ಓಕೆ, ಅಂಡರ್ಸ್ಟುಡ್? ಲೆಟ್ ಮಿ ಎಕ್ಸ್ಪ್ಲೈನ್. Here, let AB be the line segment. Assume that points P and Q are the two different midpoints of A and B. Now, P and Q are midpoints of AB. Therefore, we can take this AP is equal to PB. When P is the midpoint of the line segment AB, we can take AP is equal to PB. And again like that, when Q is the midpoint of the line segment AB, we can take this AQ is equal to BQ. Now we got two equations. Let us take the first equation now. That is what? This AP is equal to PB. Now you have to add AP to both the sides. Yes, here I added AP plus AP again to LHS. It becomes PB plus AP. Now simplify it. AP plus AP is 2AP. And PB plus AP is equal to AB, isn't it? This PB and AP. How we can say this PB plus AP is equal to AB? Yes, according to axiom 4. What it says? Things which are coincide with one another are equal to one another, isn't it? Alva, illi ಒಂದು ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ PB ಮತ್ತೆ AP ಎರಡು ಒಂದು ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಎ ಬಿ ಅನ್ನೋ ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಮೇಲೆ ಕೋಇನ್ಸೈಡ್ ಆಗಿದೆ. ಹಾಗಾಗಿ ಅದನ್ನ ನಾವು ಇದರ ಬದಲಾಗಿ ಪಿ ಬಿ ಪ್ಲಸ್ ಎ ಪಿ ಬದಲಾಗಿ ಎ ಬಿ ಅಂತ ಹೇಳಿ ತಗೊಂಡೆವು. ಅದೇ ತರ ಈಗ ಇನ್ನೊಂದು ಈಕ್ವೇಶನ್ ಇತ್ತಲ್ಲ, ಯಾವುದು? ಎ ಕ್ಯೂ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ಯೂ ಬಿ ಕ್ಯೂ ಅಂತ ತಗೊಂಡಿದ್ದೇವಲ್ವಾ? ವೆನ್ ಕ್ಯೂ ಆಸ್ ದ ಮಿಡ್ ಪಾಯಿಂಟ್ ಆಫ್ ಎ ಬಿ ಆದಾಗ ಆಗ ಎ ಕ್ಯೂ ಪ್ಲಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಕ್ಯೂ ಬಿ ಅನ್ನೋ ಈಕ್ವೇಶನ್ ಅನ್ನ ತಕೊಂಡು ಎ ಕ್ಯೂ ಅನ್ನ ಎರಡು ಕಡೆ ಆಡ್ ಮಾಡುವ. ಎರಡು ಕಡೆ ಆಡ್ ಮಾಡಿದಾಗ ನಮ್ಗೆ ಏನ್ ಸಿಕ್ಕಿತ್ತು? 2AQ is equal to AB. Again, QB plus AQ. Here, QB plus AQ. According to axiom 4, the line segment AQ plus BQ is coincide with the line AB. So they are equal. So instead of this QB plus AQ, we can take the as AB. So here we use the axiom number 4. And observe the equation number 1 and 2 here. Here, these two AB is common to both equations, isn't it? So, according to axiom 1, you know that things which are equal to the same things are equal to one another. So, can we take this 2AP is equal to 2AQ? Yes. Here, 2AP is equal to 2AQ according to axiom. And also you know that things which are double of the same things are equal to one another. Which axiom that is? Yes. Axiom number 6. Hello, axiom number 6 ಅಲ್ಲಿ ಏನಂತ ಹೇಳಿದೆ? Things which are double of the same things are equal to one another. ಅಲ್ವಾ? ಒಂದೇ ವಸ್ತುವಿನ ಎರಡರಷ್ಟು ಒಂದಕ್ಕೊಂದು ಸಮ ಅಂತ ಹೇಳಿದ್ದೇವೆ. ಹಾಗಾದ್ರೆ ಇದು ಒಂದೇ ವಸ್ತುವಿನ ಎರಡರಷ್ಟು ಅಲ್ವಾ? ಹಾಗಾದ್ರೆ ಅದೆರಡು ಕೂಡ ಒಂದಕ್ಕೊಂದು ಸಮ ಅಲ್ವಾ? So we can say that AP is equal to AQ since axiom number 6. Axiom number 6, what it says? Things which are double of the same things are equal to one another. So we proved AP is equal to AQ. ಅಲ್ವಾ? ನಾನು ಏನಂತ ಹೇಳಿದೆ? P ಮತ್ತೆ Q ಎರಡನ್ನೂ ಕೂಡ ಒಂದೇ ಪಾಯಿಂಟ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನಂತ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕಂತ ಹೇಳಿದ್ದೆ? AP is equal to AQ ಅಂತ ಹೇಳಿ ಪ್ರೂವ್ ಮಾಡ್ಬೇಕು ಅಂತ ಹೇಳಿದ್ದೆ ಅಲ್ಲ? Yes, I got you. AP is equal to AQ. So, can we say, ಈಗ ಹೇಳ್ಬೋದಾ? P ಮತ್ತೆ Q ಎರಡು ಬೇರೆ ಬೇರೆ ಅಲ್ಲ, ಒಂದೇ ಬಿಂದು ಅಂತ. ಯಾಕಂದ್ರೆ AP is equal to AQ ಆಗಿದೆ ಅಲ್ವಾ? ಹಾಗಾದ್ರೆ ಇದೆರಡು ಒಂದೇ ಜಾಗದಲ್ಲಿ ಇರ್ಬೇಕಲ್ವಾ? ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಅಲ್ವಾ? AP ಡಿಸ್ಟೆನ್ಸ್ ಮತ್ತೆ AQ ಡಿಸ್ಟೆನ್ಸ್ ಸೇಮ್ ಅಂದ್ರೆ ಅದೆರಡು ಒಂದೇ ಕಡೆ, ಒಂದೇ ಜಾಗದಲ್ಲಿ, ಒಂದೇ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇದೆ. ಅಂದ್ರೆ ಅದೆರಡು ಬೇರೆ ಬೇರೆ ಅಲ್ಲ, ಒಂದೇ ಪಾಯಿಂಟ್. Yes, thus we conclude that P and Q are the same points. This contradicts our assumption that P and Q are two different midpoints of AB. Thus, it is proved that every line segment has one and only one midpoint. I hope you understood, children. Okay, let us move on to our next problem. That is in the figure 5.10. Yes, here it is. If AC is equal to BD, here this AC is equal to BD, they given that. Then we have to prove that this AB is equal to this CD. Okay, you understood? They given that AC is equal to BD. Yes, let me solve. They given that AC is equal to BD, and can we write this AC as AB plus BC? Yes, according to axiom 4, you know that things which are coincide with one another are equal to one another, isn't it? So, this AC is the line segment which is coincide on the line AB plus BC. So, these two lines are equal. AC is equal to AB plus BC. And again, like that, BD, this BD is the line segment which is coincide on this BC plus CD. So, they are also equal. And I have taken this BD is equal to BC plus CD according to axiom number 4. And they given that this AC is equal to BD. And so this AC is equal to BD. When LHS is equal, RHS also equal, no? So, when AC is equal to BD, this AB plus BC is equal to BC plus CD. Here, in this equation, this BC is common to both LHS and RHS. And also you know that according to axiom number 3, if equals are subtracted from equals, then the remainders are equal. No? Here, these two are the equals, which are get subtracted, and the remainders are this AB and CD. These two are equal. This is what you have to prove. AB is equal to CD. Yes, hence you proved it. Okay, children, you understood? Let me move on to the last problem in our exercise. Yes, here it is. Why is axiom 5 in the list of Euclid's axioms considered a universal truth? Note that the question is not about the fifth postulate. Yes, this is a axiom number 5. Yes, what it says, axiom number 5. Yes, the whole is greater than the part, isn't it? This is universal. The whole is greater than the part. In the list of Euclid's axioms, it is considered as the axiom number 5 is considered as a universal truth because the fifth axiom of Euclid is true for all the materials in the universe. So we called it a axiom 5 as the universal truth. Yes, I completed your exercise 2.1, children. Hope you understood. In the next class, we will going to solve exercise 2.2. Before that, you should try it yourself, okay? Thank you.